This is the ÄKTA Prime in all its protein purification goodness with a computer running the ÄKTA Start software, I think it's called. I don't remember, but anyway, it has some buffer bottles on the left side. I would normally expect those to be on the right where the buffer valves are, but the computer, the mouse, all that stuff, and you can see it takes a little bit of space. Let's take a look at a close-up of the front of the Prime system here. And we can see this pump on the bottom left, and there's 4 buttons plus a keypad, and embedded in those keypad is kind of an enter and escape, something like that, back and forward kind of thing. And a pressure transducer and a mixer, and on the right side we have a buffer valve and a buffer blender, so you can choose, I think 8 different buffers for one of the components of A and B, and the other one is just fixed. There is an injection valve and a UV detector, connectivity sensor down there also. And then up to the top, today's topic is the fraction collector, which it looks a lot like a bowl or a record player of some sort or another. That arm thing on the top with the red knob, that's what we're going to be taking apart today. So let's get right into it. This is the arm of the Frac 950, or the ÄKTA Prime and Prime Plus system. This is the collection arm off the top of the fraction collector. Maybe if you've used these, this would be a more familiar view. Looks a lot like a turntable arm, doesn't it? Looks like something you'd see on a record player EP album thingy. So this is the tube that comes from the chromatography goodness and heads down into collect into the tubes. Not very much going on down there. The tube goes right through what looks like a fitting, but it's actually just a way to hold the tube. So the way you cut the end of the tube is quite important, and that's going to form the drops that go into the tube. So we'll take that off. I'll take the other end off the valve here. This is the collection valve that chooses whether to go to waste or to collect into this arm thingy. So we'll take that off. There are 2 wires that are here, and they're twisted together coaxially. There's a coil cord, and the coil cord is the drop sensor. Goes up inside the arm. I don't know if you can see that very well, but everything's black. Goes up inside the arm. And the other one, which is a mini DIN plug, 2 pins in there, yeah. That's just the 2 armature coil for the solenoid in this valve. And the valve, I believe, is just pushed in a rubber housing here. Like that. So there's the valve, a Takasago. It's a 3-port valve, Takasago part. Real easy to understand and replace. It's been private labeled by Amersham Biosciences, but it's a really common valve. So we can certainly take a look at that too if anybody's interested. Let me know in the comments. They've gone to great lengths in this part to keep it from rusting, including these plastic screws, these nylon, I think they're nylon screws here. The flathead slot in the top. So we'll take those off, and then we should get a little bit better view of underneath here. There are 2 things going on under here. One is the drop former, and the other is the tube guide. So this is the tube guide here, and it's selectable right here whether you're going to large tubes or small tubes. And it adjusts this camming action right here so that you're on the center of the tube. Large tubes, of course, you'd want this follower to be over to the side more because the diameter is bigger, and smaller tubes you would want it to be, I can't do it, more centered. All right, so let's take this plate off of here and see what that leaves us underneath. I wonder if there's any circuitry under here, or if it's all, well, we might have to take out that screw too. There is a stainless steel screw down here, I have to say. I would have thought it'd all be plastic if they went through those efforts in the visible one, but they're not. Oh, yep, that was necessary. Okay. There is a little board down here. Let's pop off this connector. It's four conductors rather. So there is a board down here with a looks like a capacitive sensor right here, and then a phototransistor and an LED and a phototransistor. So I'm mostly curious what's going on with this capacitive sensor right here. So I'm going to want to look into that. There's also a spring, as you'd imagine, to return this. And there's a snap ring up here. Let's see if we can get the snap ring off in a stupid-like way, or if I'm going to have to get a snap ring pliers. Probably going to have to get a snap ring pliers. Yeah, I'll have to get a snap ring pliers. So let's pop that little feller out and see what we've got underneath. And we can remove this. We can also remove this board. That leaves us with the spring-loaded doohickey. Okay, and this paddle-like thing. I'm afraid that's bonded together. I believe it's bonded together. Not well enough, though, is it? See if we can get that apart without destroying. Oh, it's got some snappy little pins in there, too, it looks like. I think there's adhesive in it. Which, you know, sometimes adhesives don't stand the test of time, but this stuff is standing the test of time. Oh, it's a membrane switch, isn't it? Interesting. That's meant to tell if there's a tube there or not. It is a regular dome membrane switch. Nothing terribly exciting. How cool. How completely cool is that? There it is. So when this wobbly little bit presses on a tube, it presses this membrane switch which says tube present. And if there's no tube, well, then it doesn't press on the wobbly little bit. It doesn't press on the doohickey membrane switch, and therefore doesn't make connection. So let's take a little, we're going to do a little reverse disassembly here. Some people might call that assembly. We'll clean that adhesive off with a bit of isopropyl, and we'll just snap that back together. That was well worth taking that apart. I did not know that was there. Looks like that's heat riveted in, actually. So I'm not sure I'll be able to clip it together without some surgical work. But I did. Okay. Yeah, so that's a membrane switch. Tick, 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 tick. Cool. Then we have this board, which on quick look is probably amplifying, is driving the LED. It's got a transistor, a number of passive, a couple of diodes on there, a couple of capacitors out here. Yeah, not too much going on. Driving an LED and amplifying the photodiode on the way back out. Nothing too exciting. And that's pretty much it for what's under this arm. I didn't really expect it to be amazing, but yeah, that's pretty much it. Let's see if we can
take apart this valve. I know I said I may or may not, but looks like we have a couple extra minutes, so let's do that. These are diaphragm valves. If I have my Phillips over here. These are diaphragm valves, and that means they have a solenoid that drives a small diaphragm to open and close. And let's see what we can do here to get into it. A little bit disorganized today. Apologies for that. Alright, I got my Phillips. So in here will be a Teflon diaphragm. There will be an armature that moves up and down with the valve, and there will be a reverse spring and a spring cap in here. Let's find all that stuff. So there's the reverse spring and the spring cap. You can see that down there. There's the armature. So when the solenoid valve actuates, that pulls in. And when it's not actuated, it puts full force downward on this part. And everything left in here, so this is screwed together, or put together, I should say. So it might be harder to take apart than I was hoping. There's the spring cap. The spring cap distributes the force of the spring over that diaphragm. So it's a stack of diaphragms with what I call a dog bone in there. Let's see if that is going to come apart. You know, I don't really want to ruin this one. Maybe I'll take apart another one that I have that's easier to disassemble. Time for post-processing.